Hi everybody. Today we're going to talk about right triangle trigonometry. We've talked a little bit about right triangles so far. You know that a right triangle has a right angle in it, and the sides that are touching the right angle are called the legs. The side that's not is called the hypotenuse. We've also talked about the Pythagorean theorem. A squared plus b squared equals c squared. This theorem is really helpful if you're looking for a missing side of the right triangle. But what if you don't have enough information? Or what if you're trying to find the angle inside of the triangles? That's where trigonometry comes in. So your first fill in the blank is trigonometry, means measurement of triangles. And so we want to create trigonometric ratios. Remember, a ratio is a comparison of two things. So if you take a look at this triangle, and if you have the handout in front of you, if you printed that out, you've got the picture of your triangle ABC. Capital letters are used to label the vertices of each triangle. Lowercase letters are used to label the lengths of the sides. And so little a is going to be the length of the side opposite angle A. And if we're focused on just angle A, then we're going to say angle little b is the length of the side adjacent to angle A. So notice that's touching angle A. Opposite means it's not touching. And then little c is the side of the hypotenuse. And the hypotenuse is always the side that's opposite the right angle. All right, so we can create our comparisons or our trigonometric ratios. And so the first one's called sine, sine of A, but we abbreviate it with just three letters, S-I-N. And so the sine of A is the side opposite of angle A, so that's our little a, over the hypotenuse, and it creates a fraction of A over C. The cosine of A, which we abbreviate as just COS, is the side adjacent to angle A, so that's little b, over the hypotenuse. So that creates a fraction of B over C. And then the tangent of A, which we'll abbreviate as TAN, is the side opposite angle A, which is that little a, over the adjacent side to angle A, so little b. So we have a fraction of A over B for that. So notice that sine and cosine both have a denominator of the hypotenuse, but the tangent uses the two legs of the right triangle, A over B. Let's take a look at an example and try to create these trigonometric ratios. So we want to find the sine, the cosine, and the tangent of angle A. We have a triangle here that has a side opposite A marked with a 5 and the side adjacent to A marked with a 12. But remember, to find sine and cosine, we need to have the hypotenuse, and that's not labeled here. So we're actually going to backtrack a little, and we're going to start with the Pythagorean theorem to find that missing side, the hypotenuse. So remember that that theorem is a squared plus b squared equals c squared. Since we're looking for c, maybe we can rearrange this. C squared equals a squared plus b squared, whatever you're most comfortable with. But we can substitute in for a because that's the side marked with 5. And then b is equal to 12. Go ahead and raise those numbers to the exponents. So 5 squared is 25. 12 squared is 144. Add those values together, and that equals 169. But remember, this is what c squared is equal to. So we need one more step and do the opposite of squaring, which is the square root. And so the square root of 169 is 13. So now we know that missing side of 13. Now we can create the appropriate trigonometric ratio. So let's go ahead and start out with the sine of A. So this is the side opposite angle A over the hypotenuse. So remember, our side opposite is 5, our hypotenuse is 13. So that's going to create a fraction of 5 over 13. Next, we want to create the cosine of A. So that's the side adjacent to angle A over the hypotenuse. So creating our fraction, filling that in, we need a numerator of 12 over the denominator of 13. So adjacent over hypotenuse gives us 12 over 13. And then the tangent of A is the side opposite angle A over the adjacent side to angle A. So that's going to give us a fraction of 5 over 12. Okay, opposite over adjacent for tangent of A. And we have just found our 3 trigonometric ratios for this particular right triangle. For example 2, we have the angle A, and we have one of the sides of the right triangle, but we want to find the other leg. So we're going to find A in the right triangle. So to do that, we have to figure out what are we given, and therefore which ratio is the best one to use. So we have this angle A, which is 40 degrees, and we have the side that's adjacent to it. We're trying to look for the other leg of the triangle, which is the side opposite. So remember the ratio that uses the opposite and the adjacent? That's where the tangent ratio comes in. Okay, so we have a known angle of 40 degrees, and we don't know the opposite side. We're going to mark that with our unknown of A, but we do know the adjacent side, which is 150 centimeters. So our tangent ratio, we have, remember we're doing the tangent of A, which is going to be equal to the opposite over the adjacent. All right, so we know A, that's 40. We don't know the opposite, that's our A, and we know our adjacent of 150. So here's what it's going to look like. Tangent of 40 degrees equals A over 150. Now that we filled in what we know, we can use this now to solve for A. So to get A by itself, we want to get rid of the denominator here, so we can multiply by that least common denominator, 150, but if I multiply it to the right, I have to also multiply it to the left. So that's going to cancel our 150s on the right. So now we have the A all by itself, and it equals 150 times the tangent of 40 degrees. Now that you've got an A by itself, now you can use your calculator to figure out an approximate answer for this. So in your calculator, you may have a scientific calculator or a graphing calculator, but either way, you should have a button on there that says TAN, T-A-N. So to put this into your calculator, first type the 150, then hit the TAN button and fill in the angle, which is 40, and hit equals. So I put my little squiggly equal sign here because it's not possible for me to write all of the decimal that comes in this calculator here because it goes on forever beyond what I can see in the calculator. So I'm going to round that. Let me start with 125, and I'll put a couple decimals after that, 8, 6. Okay, and so the 4 is the next digit, so I'll leave it at a 6. But what if you're asked to round it to the nearest whole number? So that would be this digit right here. So in that case, next look to the next digit to the right. If that digit is 5 or greater, you're going to raise that to a 6. But if that next digit is less than a 5, then you're going to leave it where it is. So because it's an 8, we're going to round that further to 126. So side A is approximately 126, don't forget our units, of centimeters. All right, so these are two good examples of just a basic right triangle, but trigonometry is actually used a lot in the real world. So let's take a look at some applications of this. There are two particular angles that are very helpful in trig for short. The angle of elevation is the angle formed by a horizontal line and the line of sight to an object that is above that horizontal line. And the angle of depression is the angle formed by a horizontal line and the line of sight to an object that is below the horizontal line. All right, so let's say you're this person in this picture that's standing on the balcony. Okay, you create a horizontal line to the ground from your eye level, and anything above that creates an angle of elevation. So this person looking at the airplane creates that angle of elevation because it's above the horizontal line. But then if you're looking down at something, like maybe you're looking at that car down there, then the angle created below that horizontal line is that angle of depression. So depending on where the line of sight is, you're going to look for either that angle of elevation or angle of depression. So taking a look at example number 3. We want to find the approximate height of this tower. So imagine that you're standing on the ground. Okay, here's our little stick figure standing on the ground. Hello. And so we want to approximate how high this tower is. Well, there's a couple ways we can do that. We know the distance from the person to the base of the tower. It's 125 feet. And using a tool, we can measure the angle of elevation, which is 57.2 degrees. So notice the missing side over here is A, okay, it's this side. We've created a right triangle here with our line of sight. And so the height of the tower is the side that's touching the right angle. So we have the opposite to angle of elevation and the side adjacent to the angle of elevation. So again, that brings us to our tangent ratio. So using that tangent ratio, we can set up that equation. The tangent of A equals the opposite over the adjacent. So in this case, angle A is 57.2. The opposite is unknown, so we're going to use that letter A. And the adjacent is 125. So filling in what we know, here's what we got. So similar to what we did in the last example, we can solve for A by multiplying both sides by 125. So the denominator cancels out. We've got A all by itself now. So A equals 125 times the tangent of 57.2. So I'll give you a second to put this into your calculator. See if you can do this without me this time. So remember, you want to type 125 first, the tan button, then 57.2, and then hit equals. And that gives you, in your calculator, you should see 193.962, and so on. Okay, it goes on forever. So if you round to the nearest whole number, notice that the next digit is a 9. So instead of leaving it at a 3, we're going to raise it to approximately 194, and our units this time are feet. So that tower is approximately 194 feet tall. And then in our last example, we're going to try to figure out what that angle of elevation is. So here we have a building that's 21 meters tall. And then notice that the sun casts a shadow. So the sun is behind the building. It casts a shadow of 25 meters long. So, you know, with building plans, you can figure out how tall a building is. You can measure out the shadow. And with this information, notice that we create a right triangle with the side of the building and the shadow of the legs of the triangle. And then if you draw the third side of the triangle, it leads you up to the sun. That is where that creates that angle of elevation there. We're going to call it angle A. So this time we're missing the angle. But notice that we don't have the hypotenuse again this time. We have the opposite side and the adjacent side. So again, tangent is going to be very helpful here. Had we had the hypotenuse, we could have chosen sine or cosine. But using our tangent function, we're asked to find the measure of angle A. So tangent of A equals opposite over adjacent. So this time we know the opposite, which is 21, and the adjacent, 25, but we do not know angle A. So fill in what you know, the side opposite over the side adjacent, 21 over 25. Okay, so now we got to use our calculator in a little different way to figure out what our angle is. So when you're trying to find the angle, you're going to use a function called the inverse of that trigonometric ratio. So on your calculator, you see the tan button. Above it, you should see tan with a little -1. It almost looks like an exponent. This stands for the inverse tangent. All right, so to type this in, depending on your calculator, it could go one of two ways. So our inverse tangent key, to get to that little, tan -1 that's above the button, you have to hit the second key. All right, so some scientific calculators want you to type the fraction first. So you, in parentheses, you would put 21 divided by 25, then the second key, and then the tan button. I have a scientific calculator that works more like a graphing calculator. So I, in particular, like to use the TI-30X2S. Okay, or again, you could use a graphing calculator. So in there, I'm going to hit the second button first, then the tan button, open my parentheses, 21 divided by 25, close your parentheses, and hit enter or equals. Okay, so we have second tan. Mine, the parentheses automatically open, so 21 divided by 25, close your parentheses and hit equals. And so in my calculator, I got 40.030 and so on. It goes on forever. We can approximate this answer to 40. Okay, so the display shows approximately 40. So the angle of elevation of the sun is approximately 40 degrees from the ground. So that concludes our lesson on trigonometric ratios. I hope this will help you as you go into your homework. Remember to use the tools available to you and reach out to me if you have any questions.